In this question from JEST 2024, we have a classical particle. It is undergoing simple harmonic motion. It is confined to the region minus AA on the x-axis. So we have a particle here. It is moving. It is constrained to move along the x-axis. This is the x-axis. It is undergoing simple harmonic motion. Amplitude is small a. It is going from x equal to 0 to x equal to a, then coming back, and then going to x equal to minus a, and then coming back. Now what is the question? The question is, if we take a snapshot of the particle at a random instant of time, what is the probability that it would be found in the region a by 2a? So the question is, if we take a snapshot at a random instant of time, what is the probability that the particle will be in this region, x equal to a by 2 to x equal to a? What is the probability that it will be in this region? That is the question. So to do this, we can consider a small interval of position dx. Let's say this is the small interval of position, let it be dx. Then the time it spends in this interval of position, it will be equal to dt is equal to dx divided by modulus of v of x. This is trivial. We are using just the formula time is equal to distance divided by speed. Now if we consider a complete cycle, first the particle is going from here to here, then it is coming back, then it is going from x equal to 0 to x equal to minus a, then it is coming back. So the particle passes through each point twice. It passes through each point 2 times. Therefore there will be a factor of 2 here. If we consider the complete cycle, if we consider a complete time period, there will be a 2 here. Now the probability of particle being in a small interval of position dx, it will be equal to p of x dx. This is equal to time spent in dx, divided by total time period. So the probability of particle being in an interval of position dx is equal to fraction of the time spent in dx, which is time spent in dx divided by time period. This is equal to, we found the time spent in dx here. This is 2 dx divided by modulus of v of x, and you have to divide it by time period. Now time period t is equal to 2 pi by omega, and in the case of simple harmonic motion, v of x is equal to omega times root of a square minus x square. Here a is the amplitude. So if we put these things, then we will get probability of particle being found in the interval dx. It is equal to 2 dx divided by time period is 2 pi by omega, and modulus of v is omega times root of a square minus x square. Omega omega gets cancelled, 2 gets cancelled, so this is equal to 1 by pi 1 by root of a square minus x square dx. Now to find the probability of particle being in the region a by 2 to a, we integrate p of x. From x equal to a by 2 to a. Then we will get the probability of particle being found in x equal to a by 2 to x equal to a. So this is equal to integral a by 2 to a 1 by pi 1 by root of a square minus x square dx. Now it is only a problem of solving this integration. Okay, let's do this. We can put x equal to a sine theta here. This will simplify the integral. Let's do this. But before that, I missed a plus or minus sign here in the formula for velocity. Velocity can be positive or negative as well, but when we take the modulus, only magnitude is taken, so here there is no problem, but here you have to include a plus or minus sign. Let's do this integral. We are putting x equal to a sine theta. This implies dx is equal to a cos theta d theta, and when x equal to a by 2 is equal to a sine theta. This implies sine theta is equal to 1 by 2, which implies theta is equal to pi by 6. Theta is equal to pi by 6, and when x equal to a, this implies a is equal to a sine theta, which implies sine theta is equal to 1, implies theta is equal to pi by 2. Therefore, we can write integral a by 2 to a 1 by pi root of 1 by pi 1 by root of a square minus x square dx as integral a by 2 integral pi by 6 to pi by 2 of 1 by pi times 1 by root of a square minus a square sine square theta a cos theta d theta. This is P. So P is equal to 1 by pi integral pi by 6 to pi by 2 1 by root of a square minus a square sine square theta is 1 by a cos theta, and we have an a cos theta on the top d theta. A cos theta gets cancelled, so this is equal to 1 by pi times pi by 2 minus pi by 6, which is equal to 1 by pi times 4 pi by 12, which is equal to 1 by 3. Therefore, the correct answer here is 1 by 3.